Hi everyone. Today I'm going to show you the four typical types of factoring in our math class. I will only cover the first two in details, the greatest common factor and the quadratic trinomials for this part one. And then on the second part of this video, I'm going to go deeper into the third and the fourth types of factoring. Okay, as an introduction to factoring polynomials, let's review some terminology. Okay, so when we talk about polynomials, these are the expressions that we often see in a math class, say x, okay, or 2x. Now, when we have one term in our expression, then we specifically call it monomial. So monomial from the prefix mono means single term. Now, when we have two terms combined, that means we have two terms in this expression. We can say this polynomial is called binomial. Now, once we have three terms in our expression, say you have x squared 2x plus 1. Okay, so we have this 1, 2, and 3. Now, this polynomial is now called specifically trinomial. Now, you can have more than 3. Okay, in that case, we'll just call it polynomial in general or multinomial. So you have x cubed to x squared plus x minus 5. Now, all of these are polynomials, but these specific names when we want to emphasize the number of terms in a given expression. Okay, so the first type of factoring is called the GCF. Okay, now GCF stands for greatest, okay, common factor. Now, in an arithmetic class, when we say between 10 and 12, say I'll add one more, let's say 16. What is the GCF of these three numbers? So greatest common factors, we're talking about the factors of each number here. So the factors of 10 are what? 1 and 10, 2 and 5, right? Now what about the factors of 12? For 12, we have 1 and 12. Also, we have 2 and 6. Also, we have 3 and 4. So factors are the numbers you multiply together to give you that product, say 12. Now for 16, we have 1 and 16, 2 and 8, and then 4 and 4. So we can just say 4. So what are the common factors among this group over here? So the common factors for these three groups of numbers, so we say the common factors are 1, right? What else? Do you see 2 in all of these groups right here? Yes. So 2 is also one common factor. What about the 4? Do we see 4? Okay, we only see 4 in 12 and 16, but not in 10. So 4 is not a common factor. 5 is not a common factor among these three groups. 10 is not a common factor. So in this common factor, we only have 1 and 2. And what is the greatest common factor, okay, from 1 and 2? It's obviously 2. So 2 is the GCF, or the greatest common factor. All right. So let's go to specific polynomials, and we're gonna factor it by GCF. Okay. Let's say factor by GCF. Let's say you have x squared plus 5x. Now recall in multiplication of polynomials, let's say you're asked to multiply x times x plus 5. So in multiplication, what we do is distribute this x to x and 5. So the first one is x times x is x squared. And then we multiply this x to 5. So that gives you the 5x. Right? So x is a factor. Now x plus 5 is also a factor. So when you multiply those two factors, then we get this product over here. So in multiplying polynomials, you were given two factors, or sometimes you were given more than two factors, and then you multiply to get the product. In factoring, we do the reverse process. They gave us the product, so this is the product over here, okay? And what we need to look for are the factors of this product. So we expect that there's a GCF in this expression. So the first thing we look for in a given expression when we're doing factoring is whether there's a GCF. So in this case, there's a common factor, which is x. So we say x is the GCF, and then we start factoring. So the way you do that is like you say x times what give you this x squared. So x times what give you the x squared, that's x. And then x times what give you the 5x, and that's a 5. Okay? So those are the factors, x and x plus 5. And we were able to factor the product by GCF. Okay, let's take another example. Let's say you have 2x squared plus, say, 10x. Okay, so let's factor it by GCF. Okay, what is the biggest common factor between 2x squared and 10x? So look at the number first, the coefficient 2 and 10. What number can go to 10 and 2? What biggest number can go to 2 and 10? So that will be 2. Okay? And what about the variables x? X squared and x. What's common between them? We know that this is x times x, right? So 2x squared means 2xx. Then this one is 10x. So we say that 2 is common between 2 and 10. Now, for the variables, what they have in common is 1x. So 2x is our GCF. That's one of the factors. Okay, and then let's look for what number times 2x give you this 2x squared. Then that's x. 2x times x is 2x squared. And then what number times 2x give you the 10x? That's a 5, right? So 5 times 2x is 10x. So you can, again, double check your work. If you distribute this 2x, that's going to be 2x squared. 2x times 5 is 10x. And that is equal to this given product, okay? So our factors are 2x and x plus 5. All right. So again, when you're doing any kind of factoring, first thing we do is always check for the greatest common factor. Now sometimes, let's say you have 3x plus 5, and you're asked to factor it by GCF, okay? So sometimes the only common factor is 1. In that case, you can just call it prime. There's no other way to further factor this type of expression, okay? Now, this second type of factoring is when you were given a quadratic trinomial. Say you have x squared plus 5x plus 6. So this is a polynomial. Now this polynomial has three terms, so we call it specifically a trinomial. And then the highest degree of the variable x is 2. So that's where we get this term quadratic. So this is a quadratic three terms or trinomial. Okay, so how do you factor a quadratic trinomial? Okay, so let's say, let's go back to our trinomial. So this is a quadratic trinomial. Now, there's so many ways to factor it. Again, like what I said earlier, always check for the GCF. Now, the only greatest common factor among the coefficient is 1. That means we're done with the GCF. Okay, so now you can proceed with this unique method of factoring trinomial. Now, one popular, typical method of factoring trinomial is by trial and error. Okay, so trial and error is one popular technique to factor trinomial. And the way you do it is to look at the first term x squared and find the factors of that term. So we know it's going to be x and x. Okay, x and x is equal to x squared when multiplied. What about the 6? What are the factors of 6? Now, it could be 1 and 6. Or you can have two negatives, because negative 1, negative 6 is also positive 6. Or you can have positive 2 and 3, or negative 2, negative 3. Okay, it's better to start testing the numbers that are close to each other, like 2 and 3. Okay. Now, how do we know which combinations we get? Like here, we have positive 2 and positive 3 versus negative 2, negative 3. Now, when you look at the middle sign, it's a positive 5x. Okay, so that will tell us to pick these two positive numbers, positive 2, positive 3. Okay, so we, again, look at the first term. We got this x squared. Factors are x and x. And then you go to the last term, the 6, constant. That's 2 and 3. Always pick the one that's closer to each other. Okay, and then the final way to check is when you multiply this 2 and x, that's a positive 2x, and also this 3 and x, which is a positive 3x, and then you combine those into 5x. Now you want to make sure that this matches the middle term right here. Okay, if that's the case, then the factors that we got are correct. Okay, so let's look at another example here. Say you have x squared negative 7x plus 12. Okay, so let's factor this quadratic trinomial by trial and error. Again, look at the first term. It's x squared. The factors are x and x. Now look at the 12. Okay, what are the factors of 12? 1 and 12. Negative 1, negative 12. Okay, 2 and 6. Negative 2, negative 6. Okay, 3 and 4. Negative 3, negative 4. Okay, look at the middle sign and middle number. It's a negative 7. So like what I said earlier, it's always best to start with two numbers that are closer to each other, which is 3 and 4. Now the middle sign is negative, so that tells us to use the two negatives right here. Negative 3 and negative 4 is still going to be positive 12. Okay? Negative 3 times negative 4 is a positive 12. Now let's check. This is negative 3x. Now this is negative 4x, and negative 3, negative 4 is a negative 7x. Again, want to make sure that this matches the middle term. If that matches the middle term, that means we got the combinations correct. Okay, so x minus 3 and x minus 4 is are the right factors. Okay, and you can foil it out to check, okay, whether we got this given trinomial. Okay, let's do one more. Okay, using um, this trial and error method. Okay, say you have 2x squared plus 10x plus 12. All right, I want to emphasize that every time you do the factoring, you want to check for the GCF. Okay, let's say this is quadratic trinomial. You say, okay, I know this is quadratic trinomial, and I need to use this trial and error method. But before you jump into trial and error method, you want to check for the GCF. Like for 2, 10, and 12, there's a GCF 2. Okay, so start doing the GCF first, because if you do the GCF first, then the next step of factoring will be easier. Okay, so what number times 2 equals to x squared? So that's 2x squared. And then 2 times what number give you this 10x? Okay, so 2 times what number give you the 10x? That's a 5x. And then 2 times what number give you the 12? So 6. Now this 2 as the GCF, all we need to do is just bring it down, okay, before we do this trial and error method for our reduced quadratic trinomial. Okay, so let me clean this. All right, so start thinking about how you factor this trinomial again. So we do the x squared first. Factors of x squared will be x and x. And then we go to factor the 6, which is positive. Again, we have 1 and 6, 2 and 3. Best combination to start with is the 2 and 3 because they're closer to each other. I chose the positive 2, positive 3 because the sign of the middle term is a positive. Okay, so this is positive 2x, and that's a positive 3x, and that equals 5x, which is equal to the middle term. So this will be our final factors. All right. I'll be working on the number 3 types of factoring, number 3 and 4, on the next video. Okay, I hope you learned something from this presentation, and I thank you very much for watching.